Alrighty then. 7.4, properties of special parallelograms. Special parallelograms, this goes in your notebooks. Rhombus, rectangle, and square. A rhombus is a parallelogram with 4 congruent sides. It's always going to be a parallelogram as 4 congruent sides. A rectangle is a parallelogram with 4 right angles. It's always going to be a parallelogram. A square is a parallelogram with 4 congruent sides and 4 right angles. A square is not only a parallelogram, but it's also a rectangle and it's also a rhombus. That's the most precise one, is a square. In fact, if you look at this one, right, by the way, this needs to put in your notebook, page 388. Rhombus, rectangle, square. Okay. On this one right here, this is page 389, but on this is a Venn diagram. These are parallelograms. Rhombuses have 4 congruent sides. All of these are rhombuses. Rhombuses could be a square, or they could be a rhombus that's not a square. Rectangles, these are all rectangles. A rectangle can be a square, or it could be a rectangle that's not a square. But these are all going to be rectangles. So a square is always a rhombus, a square is always a rectangle, a square is always a parallelogram, a square is always a quadrilateral. Okay? Boom. Now some special properties of the rhombuses. The rhombuses diagonal theorem says a parallelogram is a rhombus if and only if its diagonals are perpendicular. So here's a rhombus, here the diagonals are perpendicular. So you start off, if this is a rhombus, that means the diagonals have to be perpendicular. Well, we know since it's a rhombus, it has to be a parallelogram. And in a parallelogram, the diagonals bisect each other. So this diagonal and that diagonal will bisect each other. Okay. This is a parallelogram. So this diagonal and this diagonal will bisect each other. Okay. What else we know about a parallelogram? The opposite angles are congruent. So angle U and angle Y are congruent. Angle T and angle X are congruent to each other. Okay. So rhombus's diagonal theorem, a parallelogram is a rhombus if and only if its diagonals are perpendicular. So if you have a parallelogram, and the diagonals are perpendicular, then it will be a rhombus. Okay. The next one says a rhombus opposite angles theorem. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Well, if you have a parallelogram and this diagonal bisects this angle and this angle, and the other diagonal bisects this angle and this angle, boom, that's a rhombus. That's what this states right here. Okay, so you need to put this in your notebooks as well, right here, page 390. So these 4 angles are congruent to each other, as well as these 4 angles are congruent to each other. Okay, that's what this theorem states. And when's the next one? Page 391. On the page of 391. A parallelogram is a rectangle if and only if its diagonals are congruent. Okay, so if you have a parallelogram and this diagonal are congruent to each other, QS is congruent to PR, that's going to be a rectangle. So we know that this is the midpoint. They bisect each other. That's the midpoint of both diagonals. But if this distance and that distance is congruent to that distance and is congruent to that distance, all 4 of these are the same distance, that means this is a rectangle. Okay, it's not saying if you have a quadrilateral and the diagonals are congruent, it's going to be a rectangle. No. It says if you have a parallelogram and the diagonals are congruent, you will have a rectangle. Okay, there's a difference, because if we can get something like this, we can get diagonals like this. These diagonals will be the same length, but that's not a rectangle. It's not even a parallelogram. Okay, so it's saying rectangle diagonals theorem. It says if you're starting off with a parallelogram, then it will be a rectangle if and only if its diagonals are congruent. Okay. All right, good stuff. That goes in your notes as well. Page 391. Boom! Let's start with some problems. Number 3. For any rhombus, JKLM, decide whether the statement is always true or sometimes true. Draw a diagram and explain your reasoning. Question 3 says angle L is congruent to angle M. So, rhombus. Well, it could be a rhombus. Here's a rhombus that's not a rectangle, it's not a square. Here's a rhombus that is a square. That's a rectangle, but it's not a rhombus, so I'm not going to draw that one. That's not going to count here because it's not a rhombus. It's a rectangle, but it's not a rhombus. So in this case, we're going to use this one and this one. Angle L and angle M. L and M. Are they congruent? Yes, they are congruent in this case. What about this case? Angle L and angle M. Are these congruent to each other? This is an acute angle. This is an obtuse. Less than 90, more than 90, they're not congruent. Doesn't work here. They are congruent here. So, it's not always. It's not never. I wonder what the other possibility would be. It's not always. It's not never. I wonder what the other possibility would be. Okay. Next one, number 9. Nueve. Excuse me, number 9. Classify the quadrilateral. So we have to say, well, is it just a quadrilateral? Is it a parallelogram? Is it a rectangle? Is it a rhombus? Is it a square? What is it? So classify. So this diagram number 9 looks like this. Okay. Make it come out to expand it and actually zoom in. It looks something like this. Now this book is notorious for doing stuff like this. Oh, these 4 angles are congruent. Hey, these 2 angles are congruent and these 2 angles are congruent. This has 2 arcs, they're congruent to each other. These have 1 arc, they're congruent to each other. Most other books don't do it this way. Most other books do something like this. 1 hash mark, 1 hash mark. Those angles are congruent. 2 hash marks, 2 hash marks. That means these 2 angles are congruent to each other. They're not congruent to these 2 because they only have 1 hash mark. These have 2 hash marks. So one set of angles that are congruent is a second set of angles that are congruent. This means the same thing. It's just done a different way. To me, this book is more confusing when they do that, but 2 different ways of saying the same thing. Okay. Question number 9. That means something like this. So that's referring to this quadrilateral, not that one. It's the one highlighted in yellow. Yellow. Amarillo. Oh, yellow. Boom, boom. So this is a quadrilateral, has equilateral. It is also equiangular. Wait, equilateral and, well, if it's, parallelogram, yep. Opposite sides are congruent. Is it a rectangle? Yep, because it has 4 congruent angles. Is it a rhombus? Yep, has 4 congruent sides. Is it a square? Yep, because it's equilateral and equiangular. So the most precise one, square. It's a square. Okay. Of these, so the square is most precise. So you put the most precise one. It's a square. Okay, number 15. Number 15. Find the measures of the numbered angles in a rhombus DEFG. DEFG. So angle rhombus DEFG. So in this DEFG, so we know it's a rhombus. It says it's a rhombus. So hey, we know a rhombus is always going to be a parallelogram. So the opposite angles are going to be congruent. Okay. So angle 5 is the same as this, 106. The consecutive angles of a consecutive angles of a parallelogram. Consecutive angles of a parallelogram. There we go. Opposite angles are congruent. Opposite angles are congruent. And consecutive angles, these are consecutive angles. They're, what's up? Hey, what's up? Sup, sup, sup. Supplementary. These are supplementary, they add up to 180. These 2 are consecutive, they are supplementary. These 2 are consecutive, they are supplementary. These 2 are consecutive, they are supplementary. Okay, so That means in this case here, angle 3 plus angle 4, that entire angle, plus 106 is equal to 180. So 106 plus angle 3 plus angle 4 is going to be 180. Oh, wait a minute. We also know that because it's a rhombus, because it says the instructions, this diagonal is going to bisect that angle and bisect that angle. Okay, so that means these two angles are congruent. So we can say 106 degrees plus angle 3 plus angle 4 equals 180 degrees. We know that. We know angle 3 and angle 4 are congruent. So 106 degrees plus, let's say, 2 of angle 3, because angle 3 and angle 4 are the same measurement. 180. So 108, we're going to subtract 106 on both sides. So minus 106, we get 74. So we're going to divide both sides by 2. This is going to be angle 3. On this side, this is for 80, 36, 37 degrees. Angle 3 is 37 degrees. That's 37. Angle 4 is 37. That's 37, that's 37. 37 degrees, 37 degrees, 37 degrees, 37 degrees. Bada bing, bada bang, bada bang, bada boom. Bam! Done. So angle 5 is 106 degrees. Angle 1 and angle 2 and angle 3 and angle 4, they're all 37 degrees. Okay. Next one, numero 24. 24. Number 24. Where is my 24? Here's my 24s. I'm going to take this right here. Take this right here. 32. Ooh, it's finally got units. Look at that. Nice book. Determine whether the quadrilateral is a rectangle. So 32 meters, 32 meters, 21 meters, 21 meters. Nice. Okay. It has one right angle. It has one right angle. Huh. It has one right angle. Well, we know a rectangle is always going to be a parallelogram. Opposite angles in a parallelogram. Congruent. So if that's 90, this is 90. We know the consecutive angles will be supplementary. What's up? Okay. So 90 plus what is 180? 90 plus something is 180. 90. So this one, supplementary angles. This plus something is 180, it's 90. Or you can say opposite angles are congruent, 90 is 90. So if you have one of them, if you have a parallelogram and just one of these is 90 degrees, boom, you know all four are going to be 90 degrees. Okay? So now you have a rectangle, because you have a parallelogram with 4 right angles. Boom, that is a rectangle. Done. Question 24. Yes, it is a rectangle. The next one we have, name each quadrilateral. So it's either going to be a parallelogram and or a rectangle and or a rhombus and or a square, for which statement is always true. So it is equiangular and equilateral. So a quadrilateral is equiangular and equilateral. Is it always going to be a parallelogram? Is it always going to be a rectangle? Is it always going to be a rhombus? Is it always going to be a square? You have 4 choices. These are your 4 choices. You have to write all the ones that satisfy that statement. So, number 30, it is equiangular and equilateral. Equiangular and equilateral. So this is equiangular. Is it equilateral? No, all 4 sides are not congruent. So it's not that. This is, what am I saying? Here we go. This is equilateral. Yes, it's equilateral. Is it equiangular? No. Not that. Ooh, here we go. This is equilateral and it's equiangular. Oh, there you go. Let's talk about something like this. Now this right here, could this be, is this always going to be a parallelogram? C. This right here, is this always going to be a rectangle? C. This right here, is it always going to be a rhombus? See, this one right here is just always going to be a square. See, what? So this is, that right there is always going to be a square. It's always going to be a rhombus. It's always going to be a rectangle. And it's always going to be a parallelogram. All four of them would work for question 33. So you have to write down all four. Number 33. The diagonals bisect each other. 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 Here's diagonals. So this diagonal right here, does this diagonal bisect no, so it's not this. That doesn't work. Diagonals bisect each other. Where's that diagonals bisect each other? Diagonals bisect each other. Right here, the diagonals bisect each other? Yes. This diagonal bisects that angle and this angle. This diagonal bisects that angle and that angle. Bada bing, bada boom. So this is what they mean for question number 33. The diagonals bisect each other. So this right here is this always, is that always going to be a parallelogram? Yes. Is that always going to be a rectangle? No. Oh, it's not going to be a rectangle. The diagonals bisect each other. Oh. I read that wrong. The diagonals bisect each other, not the angles. Those angles. This diagonal does not bisect each other. Okay. Yes. I read it. I'm thinking about the angles. So my bad teacher. Bad. So the diagonals bisect each other. Number 33. So this diagonal and this diagonal bisect each other. Yes. So that. So we have. Let me give you a better idea. Those diagonals bisect each other. So it's a parallelogram, yes, because all of the diagonals will always bisect each other. Okay, for a rectangle, do the diagonals, for a rectangle, where's my rectangle? Here's my rectangle, no, where's it? There it is. Here's my rectangle. So for a rectangle, do the diagonals bisect each other always for a rectangle? Yes. This is the midpoint of the diagonals, yes. What about a rhombus? For a rhombus, if it's a rhombus, do the diagonals bisect each other? Yes, that's the midpoint of both diagonals. What about a square? Where's my square? My square. Here's my square. For a square, do the diagonals bisect each other? Yes, the diagonals bisect each other for a square. Yes, since it's a parallelogram, it's always going to work, okay? Because a square is always going to be a rhombus, a square is always going to be a rectangle, and a square is always going to be a parallelogram, okay? Next one, last one, number 66. Question 66 here, number 6. Complete each statement with always true, sometimes true, or never true. Explain your reasoning. A rectangle is blank a square. A rectangle is blank a square. So here's a rectangle. Is that a square? No. Here's a rectangle. Is that a square? Yes. Yes. That's a rectangle. It is a square. That's a rectangle. It is not a square. Oh, for 66, I wonder what you put. I wonder what we put there, because it's not always. It's not never. Huh. I wonder if it's sometimes. So let me go back here and just rephrase here on page. This is number 30. We have to start off with question 30. Whoops, bring it down so we can see it. Here we go. For parallelogram. For a parallelogram, is it equal angular and equilateral? Does it always work? So start off with this. A parallelogram. Is it always equal angular and equilateral? Okay. This is just which statement is always true. Number 30. which is always true. So is it always going to be true for a parallelogram? It's equal angular and equilateral. It's not equilateral, so it would not work for question 30. Question 30, parallelogram would not work. What about for a rectangle? Okay, that was a rectangle. Here's a parallelogram. It's not equal angular, so there we go. It's not going to work for that one. Rectangle, is it always going to be equal angular and equilateral? Nope. What about a rhombus? A rhombus. Here's a rhombus. Is it always going to be equal angular and equilateral? Well, it's equilateral, but it's not equal angular. Question 30. Square. What about a square? A square, is it always going to be equal angular and equilateral? Is this always going to be equal angular and equilateral? Yes, a square works. Question 33, do the same thing for a parallelogram. Here's a parallelogram. Do the diagonals bisect each other? This diagonal, yes, that's one of the properties of a parallelogram. Yes, it always works for parallelogram. Yes, that works. What about a rectangle? For a rectangle, that's not a rectangle. For a rectangle, does it always work that diagonals bisect each other? Do the diagonals bisect each other? Yes. What about a rhombus? A rhombus. Do the diagonals bisect each other? Is it always true? Here's a rhombus. Here's a rhombus. Do the diagonals bisect each other? Yes, because it's always going to be a parallelogram. What about a square? What about a square? Do the diagonals bisect each other? Yes, because a square is always going to be a parallelogram. So question 33. Question 33, they all work. Question 30, the answer, what was the only one worked there was a square. I think I blew it earlier there. So question 30, the only answer that would work, square. Question 33, all four of these work. There we go. That's it. We're done. Bada bing, bang, boom. Bye-bye.